It is my pleasure to bring up Dr. Jordan Adams talking about motivating effects to missions from cyber threats during operational testing. Jordan comes to us from IDA as a research staff member. He's also the project lead for cyber testing related to all land warfare systems and the deputy portfolio lead for all the systems under DOT&E oversight. Jordan received his PhD in high energy physics at the prestigious Florida State University. In 2015, he spent a year at the Center for Army Analysis before coming here to IDA, and he's been here since 2017. So please give a warm welcome to Jordan. Jordan, please.
Can you guys hear me okay? Awesome. I'm probably going to walk around, so I'm just going to use this thing. So thank you very much, Diego. For those who don't already know me, I'm Jordan. I work for IDA, and our primary sponsor in the Operational Evaluation Division is DOT&E, or the Department of Operational Test and Evaluation. So as our primary sponsor, their job is to basically assess new weapon systems to make sure they are safe, they are effective before we hand them over to the warfighter and they actually face an actual combat scenario. So our director, Heather Whiten, this morning made a very good point that, this is an incredibly important job. We want to make sure that when the warfighters actually get this stuff, it works, it's safe, they trust it, and cyber is an unavoidable part of our world, both in the private sector as well as in combat scenarios. So making sure that we do cyber testing right in OT is of the utmost importance. So with that, basically operational test and evaluation with cyber threats does inform decision making by providing examples of adversarial cyber effects to systems and this is the important part, the translated effects those have on supported missions. So this will make more sense hopefully by the end of the talk, but this really is the motivating piece of what I really want to talk about today. So quick outline, I'm not going to go through all of these, but you get the point. We're going to motivate. And then I want to talk a little bit about the evaluation strategy, how we do things now, and then just cover some of the problems that we're seeing, and then finish up with some of the recommendations of how we can actually make this process a little bit better. So DOT&E guidance is not really consistently followed. So DOT&E, as I pointed out, our primary sponsor, has a set of policy and guidance documents that say this is what you should be doing to operationally test weapon systems, and part of that is how to do so with cyber. For one reason or another, this guidance is not always followed. Sometimes there's limitations to test. There's a lot of different reasons. But by and large, testing really does need to mirror the way we fight in order to adequately assess systems. So DOT&E has a series of pillars in their strategy. Pillar 1, test as you fight. That's really the most important piece here that I'm trying to get across, is that testing really needs to mirror the way the U.S. actually will fight a near-peer adversary, and that includes cyber threats. Up here, you can see the newly released DOT&E guidance documents. There's a Department of Defense instruction, 5000.98, which is an OT&E and live fire evaluation overview, accompanied by 5 DoD manuals. Each one of these manuals has a series of guidebooks that either are or will be published. And the point of these guidebooks is really at the granular level to tell you how to actually go about testing the requirements in the aforementioned documents. The ones that are relevant to this talk are obviously the DoDI 5098, the Department of Defense Manual 5099, which is realistic full spectrum survivability and lethality testing. This covers basically multi-threat testing, kinetic and non-kinetic, which includes cyber. And then the Cyber OT&E Guidebook, published in February of 2025. So that guidebook is very similar. If you work in the community already, you may already be aware of the April 3rd, 2018 Cyber Procedures Memo, very similar to that, and the August 2014 memo before that. So how do we do things now? Basically, I want to start early. What do we mean by mission? So I talk about motivating mission effects. We need to start at the earliest part, which is the United States fields weapon systems. These systems are supposed to do a thing, whether it's a vehicle that drives soldiers from point A to point B, maybe it's an airplane that's supposed to transport equipment, maybe it's an amphibious vehicle that's supposed to take soldiers onto the shore. or a satellite system that relays communications between people on the other side of the world, it doesn't matter. Basically, systems are employed by users to serve a broader purpose. As I pointed out before, cyber is just a part of the environment. Doesn't matter what environment it is. There's lots of domains: air, space, sea. Cyber is pervasive of all of these. So it doesn't matter if it's a real-world scenario, non-combat, or an actual combat scenario. Cyber is just part of the environment. On top of that, blue forces, basically our guys trying to complete a mission, and the adversary, the red forces, both have intent. The blue forces, they're trying to complete their mission. They're trying to get that vehicle from point A to point B, or whatever it is. The red forces, the OPFOR, their job is to stop them from doing that. And this may be outright, this may be noisy, this may be very nefarious. Maybe they just want to spy, maybe they just want information. The point is each one of them have their own intent, and I'll come back to that later. The idea here is that we really need to understand each mission and the unique operational environment for this system. Cyber affects both of them. Keep that in mind, we'll come back to that later. Okay, so when I talk about affecting missions, the real point of operational testing with cyber is to affect the missions, how to get these mission effects. So what do I mean by this? Cyber effects can be translated into operational domains or translated to other physical domains. So cyber effects, when I say cyber effect, this is what happens to the system in the cyber domain. So maybe I'm an OPFOR person and I've managed to get access to a part of your system I'm not supposed to get access to. Maybe I've turned off your email server. Maybe I've intercepted a video feed and now I can see what you see. Cyber effects can translate to these other domains, but not all of these effects are mission effects, because the other domain may have an effect, but it may not be part of the mission. So, a couple of examples in the second column here. Say, for example, I can intercept a video feed from a UAV. That is a cyber effect. However, if that allows the enemy to reposition their forces and avoid destruction or create some kind of a lure for an ambush, that is now a mission effect because it's translated to another domain. I may also be able to inject false information on fuel levels for a series of vehicles, maybe an entire fleet. That's great. Maybe nobody notices, but also maybe the vehicle unexpectedly runs out of fuel because they think they have more gas than they do. I could also deny access to email and chat servers. Now your unit can't exchange any plans or orders. Stopped communication. So basically, just to drive the point home, cyber is a pervasive domain. It can affect all of the other domains. It's a man-made domain that can affect air, any kind of mission that you can imagine. I'm not going to belabor the point. So, now we really want to get to how well can the unit actually accomplish its mission while under cyber attack. So the question is can the unit overcome effects caused by cyber attacks? What I mean by this is the ability of the blue team to complete its mission, but also cyber needs to be part of the red team plan. The OPFOR gets a vote too. Basically, the bad guys can decide how to attack, and the blue force is trying to complete their mission. But cyber also needs to be part of the evaluation framework itself. The cyber evaluation needs to include aspects of both cyber defense and aggression. It's not just blue team, it's not just red team. It's easy to say, well, how are they going to hack? But blue forces have actions that have consequences just as much. By this I just mean also include cyber as a factor in existing mission designs. As I mentioned before, cyber is part of the environment. It's just like everything else, it's just another threat. So we really need to tie the cyber evaluation to things like effectiveness, suitability. It's really often that we see cyber as a part of survivability, but it can affect these other things just as easily. Maybe my cyber attacks from a red force can actually affect the effectiveness of your system or the suitability. Maybe you lose trust in it. It's not all about just turning it off and shutting it down. So, blue forces have a job to defend their system. And they do this by preventing, mitigating, and recovering from cyber attacks. So these are actually the core principles of a defensive cyber evaluation. So the Blue Force needs to be able to identify the environment and identify the tools they have at their disposal in order to protect against cyber attacks and actually use those tools to protect against things. This could be firewalls. This could be intrusion detection systems. This could be actual physical security if you're thinking about it like that. Be able to mitigate attacks when they do happen. By this I mean the ability to detect and react to cyber attacks. Do they know an attack is even happening? Can they do anything about the attack once it has started? And then can they just fight through it? Do they actually have to stop? Can they have to change to some other server stack or something? Whatever that looks like. And then finally, the ability to restore after a cyber attack has happened. So this could mean two things. This could mean, all right, I've turned it off and I've turned it back on. Now I can go on with my mission. This could mean maybe I have to re-image the entire machine. The point is there's a difference between a continuity of operations plan, i.e. a failover to doing something else and just fighting through, and actually going down at the very forensic level and making sure that the cyber bad actor is out and cannot repeat the attack again. The second is a lot more involved, and that's something we really would also like to see in operational testing, which I can come back to. Okay, by the way, I should have mentioned at the beginning, interrupt me with any questions you have. Folks on Zoom, I think we were going to wait until the end, just because a lot of that stuff was in chat. But raise your hand, interrupt me if you have anything. Okay, so I mentioned the Cyber OT&E Guidebook, which was published in February of 2025. That guidance and the guidance before it describes two different types of cyber assessments. The first is a CVPA, a Cooperative Vulnerability and Penetration Assessment. This is basically a cooperative investigation of the comprehensive attack space of a system. Basically, the intent here, the goal, is to try to find as comprehensive a list of findings, vulnerabilities, exposures as possible, so I can say where are the vulnerabilities of this system. Basically, if I'm the red team, I want to use this to say, how can we get in? Can we get in at all? Once we do get in, how can we move around? What can we do when we get there? What can we see? Can I access things that I'm not supposed to? What cyber effects can I cause? If I'm the blue team, I want to know what do I see when the red team's trying to get in. What do I do? What tools do I have at my disposal to actually stop them? Am I seeing rogue IP addresses on my network, for example? Basically, the point that I'm trying to drive home here is that this is sort of a push and pull. Cooperative is in there for a reason. The red force and the blue force both know that this assessment is happening. They're talking to each other. Sometimes they're in the same room. The idea is not to be sneaky about this. You're trying to basically see what happens when I do X and what do I do when something happens. An adversarial assessment, on the other hand, is very different. An adversarial assessment is very mission focused. So basically the question is can the red team actually affect blue team missions? So that goes without saying that you need to actually have missions happening in order for you to really answer that question well. But the idea is, can defenders actually operate against cyber aggression, and what does that do to missions? Blue teams can defend against red team actions, and maybe their actions also cause mission effects. So we talked about translated effects before. Maybe the act of defending against the red team actually causes a mission effect in and of itself. I really want to drive home that each one of these has different goals. These are complementary assessments. They are not the same. Both are owned by the Operational Test Agency because they are operational assessments. And both operational assessments in operational environments with operational configurations and operational users. I know I'm overusing this word. Basically, you can scope assessments for relevant acquisition pathways. I don't want to get too down that rabbit hole, but basically, operationally realistic is a term that needs to represent whatever decision the test is informing. So if you have a prototype, for example, the test is probably going to be representative of whatever that prototype looks like. It may not be field representative because that system is not mature enough yet, but I digress. Okay, so what are the current requirements in DOT&E guidance for operational testing with cyber? First, we're drumming on this a little bit already, but the system needs to be configured as it will be in the field, including all interfacing system of systems, joint networks, and representative amount and type of network traffic. I pointed out already that considerations for acquisition pathway, system maturity, these things are factored in. However, you really want to test the system the way it's going to be fielded. Because if you leave out huge subsections of the system, if it's not operational, if it's not configured the way it will be to inform that fielding or whatever decision it is informing, if all the people aren't there, by that I mean users, defenders, maintainers, are all the systems that are going to plug into it actually there? you're not going to get a comprehensive look at the system. You're not going to know what you're missing if it's not all there. Two, I already said this a little bit, include all the people. Defenders, operators, users, maintainers, administrators. Who's going to be touching this system? How are they going to be touching it? How are they going to be using it? You want to make sure that the training for all of those people actually represents what is going to happen. You don't want a golden crew. You don't want a bunch of PhDs out there that know exactly how the system works because they're the ones who built it. You also don't want people showing up that have never seen the system before and have no idea how to use it, because now you're not actually looking at how the TTPs affect the mission or how that system interacts with how those representative users would be using it. So you really want, this goes to operational realism as well. You also want to make sure that the cyber threats, the red team, are actually representative of what you're going to see in the field or wherever this is going. Ideally, you want this to represent near-peer adversaries. I'm talking supply chain threats, assume compromise, really sophisticated attacks. Low-hanging fruit is great, but if the only thing you find is that nobody changes their passwords, that's not a very informative test. You also want to include systems and supporting units conducting actual missions. So there are several limitations associated with this. You cannot hack an airplane while it's flying, for example, because of pilot safety. You will often find that the Army does not like to hack vehicles in formation because soldiers are operating the vehicles. There are limitations to tests that are unavoidable. However, it is possible to get those translated effects, or what the implications for those cyber effects would be, is essential to actually satisfying an operational test with cyber. You also want to make sure that data collectors from OTC or whoever are situated in a way that allows them to directly measure effects to missions following those cyber attacks. I also want to sort of point out, adversaries can also do really nefarious things like integrity attacks. It's not always about just shutting the system down or making the vehicle stop or whatever. Sometimes you just want to spy. Sometimes you just want to gather information. There may not always be mission effects depending on what cyber effect you're talking about. But my point is you need to have those data collectors there to actually see what's happening. A lot of times you'll hear, well, the cyber test teams will tell us what the mission effects are. Cyber test teams are not mission experts, so they don't really know what's going to happen to the mission. They know what's going to happen at the cyber level. And like I said, test community does not always see all of these play out. So, what are the challenges that we see with what I just said? So, where are the current gaps that we're seeing? First is lack of operational realism. So, this usually manifests in system configuration, realistic data flows. Is the system actually configured the way it would be configured in the field? Are there all of the operational defenders, users, are they trained the way they would be in the field? Big thing we see a lot is all of the tiers of cyber defenders are not present. Local defenders usually are. They're usually pretty easy because they're part of the unit, but there's also these tier 2 and tier 3 level defenders that do have a say in this as well once a system is fielded. Sometimes they're not always a part of tests. There's also a lack of cyber integration with functional testing. I'm using quotes here because functional testing is just meant to say that operational testing that does not include cyber threats. But that integration is super important because that's usually where the mission scenarios are happening. Cyber assessments you'll often see are just sort of segregated, stovepiped off to the side, like a vehicle in a motor pool, or maybe they put the cyber test team in a trailer outside, and they're not actually in any way interacting with the rest of the operational test. You're not going to get those interaction effects. You're not going to get those system-of-system interactions if you just say, okay, go over there and punch numbers on a screen. Basically, testing isolated systems instead of the actual unit operating the systems is not going to give you a full picture look. We're also seeing a lack of structured cyber attacks. Free play is super important. I want to make that clear. You don't know what you don't know. However, there should be some coordination between cyber teams. I've talked about CVPAs and AAs being complementary tests. The CVPA results should, in principle, feed the planning for the adversarial assessment. If you already know what that comprehensive attack space looks like of a system, you can use that information to sort of shape what your intended attacks are going to be during the AA and decide a priori what kind of cyber effects you plan on causing. And then you get to sort of explore what those mission effects look like in a mission scenario. But that coordination is often not there. There's also a lack of dedicated cyber data collection from operational test agencies. The effects to missions really do require data collection from mission experts, not cyber test teams. This is not a knock on anybody in particular, but a lot of times, sometimes I've seen, oftentimes you will see focus groups where they say, hey, soldiers operating the system, did you see X, Y, or Z? And they can give you direct feedback. That's great. Hearing from the users and the people actually executing the missions is basically the best that we can hope for. There's also a lack of advanced cyber attacks, such as supply chain compromises, cyber RF attacks. A lot of this is emerging. It's not easy. And sometimes the juice isn't always worth the squeeze. However, nefarious actions with lower likelihood for detection often are more representative of what we would see in the real world, so they should be included in tests. Again, we really want to get to those that are representative of near-peer threats. None of these are on purpose. None of these are by design. Again, a lot of tests have limitations, and that's just a fact of the test community. Unfortunately, it's just the world we live in, so there are ways to sort of get around these things, but we would like to see ways to improve them. So, what are those ways that we can potentially improve operational testing with cyber threats? First and foremost is improve operational realism. So it is a good idea to integrate systems under test with their interfacing system of systems. I mentioned Pillar 1 from DOT&E strategy before, fight or test as we fight. No system is being fielded without touching some other system. Even in like our private homes, we have Internet of Things. Everything is touching everything else. So whatever system you are testing, at least the interface to those other systems needs to be included because there's trust relationships. There are ways that systems can affect other systems. Maybe there's an ingress point from some other system that's not included in your test. Looking at how a system is connected to all of these other systems, how the networking was working, really needs to be taken into consideration when doing test planning. It also might require inter-program cooperation. There are it is the real world. There are different program offices, and different program offices own different systems. You're not going to get every system out to test unless there's either some motivating force, some cooperation, exercises. It may require some, creativity in getting all of this together. But you also want to make sure that all the personnel configurations are operational. So what I mean is, are they configured the way they're going to be fielded? Are they actually transmitting data? Are they transferring the level of data that you would see? What does the network load look like, etc.? And then you want to actually make sure that the training is the way it would be in the field, and I've touched on that already. Also, integrate cyber aggression into functional operational testing. So the synergistic effects of cyber threats with other threats, I mentioned full spectrum a little while ago. I'm not going to go down that rabbit hole right now, but basically the combined effects of different types of threats are really unknown. So what happens when jamming happens at the same time as cyber? What happens when cyber, maybe there's some denial of service attack in conjunction with a kinetic threat? All of these synergistic effects are not going to be known unless you're testing in a real representative environment. And that's going to take time. We're not going to do that overnight. It's going to be a real phased approach to figure out how to do that. But you really want to combine the testing of systems and threats to better evaluate these second and third order effects. Like I mentioned, full spectrum survivability. I implore people to go read the DOD&E, and you can find out more information there. Also, you want to leverage CVPA results to inform AA planning. A lot of times we'll see CVPAs happen, and then AAs come along with a different cyber test team, and they just repeat the same thing and look for different vulnerabilities. What did the program office fix in between them? That's not bad. That's good. But we can be leveraging those results more to help better shape adversarial assessments in the future. Also, more methodical data collection for cyber assessments. OTAs can be placing data collectors in cyber tests too. There's evaluators on the OTA side that are really good at this stuff. So if we know there's going to be a cyber effect, if we know there's going to be a cyber inject into missions, having those data collectors there to adequately see what happens really gives us a better amount of data collection and allows us to better evaluate systems. Carrying out more advanced cyber attacks, again, this is not an overnight fix. Cyber test teams obviously are very, very good at what they do. A lot of times it's a resource problem, but basically better representing near-peer threats is the holy grail here. How do we actually better simulate real-world cyber attacks? This is going to, again, require coordination across threats like RF cyber, electromagnetic spectrum ops, maybe even close access teams. Full spectrum I've talked about already. Supply chain attacks cannot really be underestimated. Assuming compromise is super important. And also, cyber tests really should be more efficiently scoped. So intelligence can inform, it shouldn't determine the scope, but we can really also look more at intelligence documents to say, what is the emerging threat for this kind of system? Let's make sure we include it in the AA. Let's make sure those types of threats are actually demonstrated. Test planning, MBCRA exercises, cyber tabletops can help with all of this stuff. So, almost said about a half hour. In conclusion, basically cyber is just another component of the environment. It's another, albeit complex, threat type. So, operational testing is operational testing. Operational testing with cyber is just OT with a very specific kind of threat. And what's more is we'd like to see how that threat combines with other types of threats as well. The OT community really needs to start including, well, it already does, needs to include cyber as a threat, integrated with red and blue missions, interfacing systems, users, and other threat types. The goal here is really to assess how cyber threats can affect those missions. That's really the end goal. You have a system, it needs to do something, it's going to do it in a mission. How does cyber affect the ability to complete that mission? And I cannot say this enough, cyber effects are not mission effects. The two are different. So having a list of vulnerabilities from a CVPA, for example, is not going to tell you how that system is going to fare in an actual mission. Data collection is key, and operational cyber testing is just OT while a system is cyber threatened. It's no different. Cyber testing is not any different than regular operational testing. It is just OT with a new threat. So with that, any questions from anyone? I'm happy to answer.
Hi, I have a couple questions.
Yes, of course.
First of all, when you go out to do the assessments, if you don't have the optimum, I'm probably holding this wrong, if you don't have the optimum test scenario that you want, like let's say you don't have the right people there or the right test environment, they're not operational like they're supposed to be, do you cancel the assessments? Or do you just go ahead and run it the way that it's set up currently? And then my second question is, what is the requirement for the data collectors? Thanks.
Got it. So test events are largely funded by the program offices. They are not going to not have a test. So let's say, for example, there is an operational test or an IoT or an FOT&E or something like that, and the test is more than just cyber. And you show up there and you find out that a lot of the defenders aren't actually there. No one is going to pull the plug on that test. That test is happening. Those people are there. From DOT&E's point of view, if we are going out to assess how that system is going to do, or how that adversarial assessment is going to do, we will take whatever data we can get. We will make sure we're communicating with action officers, our sponsor, make sure they're aware of what's happening. And then if there is data missing, then our evaluation may be limited because there weren't the right people there or something. So now we can't say, well, we don't know how well the system is going to be defended from that posture because those people weren't there. It may affect the evaluation down the road, but you still wouldn't cancel the test. I mean, DOT&E has the authority to say a test is inadequate if it ever comes to that. But in principle, the hope is that, there's enough planning up front so that the test isn't totally useless. It's not inadequate. There just may be limitations to test. And sometimes it's not about people not showing up. Sometimes, there are adverse things that happen. Equipment breaks, sometimes there's emergencies, conflicting test obligations, whatever. You don't always get the data that you want. And those are just, those things happen, and the evaluation can be limited as a result, but that's about it. And I'm so sorry, what was your second question? Oh, yes. So, the short answer is the data that we get from cyber test teams usually consists of whatever the cyber test teams do. So we're talking about system logs, notes, maybe even screenshots, videos, things like that. Any kind of, this is ideal. It doesn't always happen. Now, OTC, or the Operational Test Agency, whatever. Sorry, I'm biased on Army. They will have operational data collectors that are doing things that are not just cyber, and they'll be out there looking at RAM, looking at effectiveness data, whatever. They can also get data on cyber effects if they're injected into missions. So, for example, if there's a test incident report that somebody's radio went down because there was a cyber inject that caused it to go down, that data will show up in functional data as well. So part of our job and DOT&E's and really the test community at large is coordinating all of that data flow and making sure that we're matching up, hey, was this a result of cyber? Was this not? And making sure those data collectors are where they need to be to see that kind of stuff. So it's not always just cyber data. Sometimes it's other data that can be married up with cyber actions. Yeah. Anyone else or anything online?
Nothing online. I do have a question. So
Yes.
you talked about different gaps in cyber OT. Within the last 8 years that you've been working here, what are some of the improvements that have been made? And if you can pinpoint that to any sort of resourcing or policy decision, and then anything that we would need to do that's similar to that to be able to improve in the next 8 years.
So, the short answer is yes. I have seen improvement. I will admit that I work mostly, as you pointed out at the beginning, with the land warfare folks. One of the things that I talked about here was basically integrating cyber with missions. We have seen a vast improvement in that. I would argue that there's still a long ways to go, but we are seeing more and more cyber injects into missions. Try not to go into details here, but basically if there are mission scenarios happening every 72 hours or 24 hours or whatever, the testing community has done a much better job of saying, okay, well, the cyber test team's over here and they found these 7 vulnerabilities or whatever. And they are able to cause these 3 cyber effects as a result of it. And now during these missions, they're going to inject, one at a time, these cyber effects. And then we're going to see how the mission carries out. And then when things go awry, those data collectors are in the field and they see this happen. And now you've got actual mission injects due to cyber effects, and that integration has shown up. Does this happen on every test? No. And does it happen to the extent that we would like to see? Not always. But there are a good handful of scenarios of systems that have done this, and the results have been really good. What I would like to see in the future is that continuing, but also better integration of interfacing systems. So I mentioned earlier about how everything is now becoming more and more networked. The number of things soldiers have on them that are networked to other things is just getting a lot. So making sure that all of those interconnected things are at test to see what that does to an actual mission when something gets hacked. What do those trust relationships look like? Whatever. Seeing a better integration of those system of systems is something I would like to move towards, or like to see moving towards. Yeah. I don't know if that answered. Okay.
Thank you. Are there any other questions? Anything on Zoom?
Rob, you got something? Oh, never mind. Okay.
All right. Well, thank you, Jordan.